Hey, hi everyone. Thanks for actually turning up to the last session of the day. This is my second trip to New Zealand, and they've been good to me. They've given me the session before the party, the session after the party, and the very last session of the event. So I was actually not expecting anyone to hear me present. My name is Lewis Benj. I work for an advertising agency, so it's a bit weird coming back into IT and actually presenting IT content. But ironically, I work within an advertising agency, within a digital department, on a team called the Devices and Integration team. And what my actual role is people come to me with the craziest, wackiest ideas possible, and I have to build them. And I don't necessarily have to build everything, but I oversee the teams that do build the stuff, and I have to try and figure out all the impossible tasks. If I move my slides in the right direction, that would be a good start. I need to put a little disclaimer up here. I was meant to be presenting to you today on a product called the .NET Gadgeteer. I've learned this lesson a few times that when preparing for stuff, buy several of the same product because you can short it out. I shorted out my Gadgeteer when preparing this demo, so I'm actually switching it for a different platform called NetDuino. I'm using the same underlying framework, so all the code is transportable across to the Gadgeteer, and I will talk to you about the Gadgeteer, but I won't actually be using it. So heed this warning. If you try any of this at home, you may short out your stuff. So I thought it would be a good position to actually start this presentation and actually looking at Wikipedia on what a robot is. I kind of put the abstract in really, really blind because the innovation session at TechEd New Zealand is it's unique. Nowhere else in the world actually has an innovation track. And I didn't know what other types of content I was going up against. So I thought this wacky idea in about robots and talk about what we interpret as a robot in terms of advertising. And then I saw I was up against the guy that built this massive, great big Kinect-powered robot. And unfortunately, I'm going to underwhelm you slightly because my robots aren't going to be this big humanoid-style robot. And as you can see, some clever person on Wikipedia came up with this great quote, which is a robot is a mechanical device that can perform tasks automatically. So in the world of digital advertising, we actually refer to this as a digital utility. So this has been able to make people's lives easier and be able to connect with a brand on a more familiar basis. And that's done by a few different mechanisms. And ironically, robotics is one of them, but in a form that you wouldn't necessarily see as actually being robotics. As we're at a Microsoft event, I thought I would talk necessarily about a Microsoft product, and that specifically is the .NET Micro Framework. It's actually one of the oldest products that I've talked about, and I've actually worked with a few fairly old products, but this one is a good one. In my day job, I work with a whole load of embedded platforms. The majority of them are Microsoft, but I've also worked with Raspberry Pis, I've worked with Arduinos, and a few other bits and pieces, but this one's one of my favorites. And the main reason for that is because I'm a C# developer by trade. I've come from an IT background where I've worked on ASP.NET and Silverlight and a whole load of things from Python. So, .NET Micro Framework, I just wanted to put into context of where it actually is in today's market. So we've got these great products, Windows 8, we've got Windows Embedded, and we've got the Micro Framework. They sit across this whole massive, very big IT ecosystem that we now have. And the lines are starting to blur and blur, especially nowadays with Windows 8 being able to work on system-on-a-chip architectures. If we went back 2 years ago, so in the days of Windows 7, and I was given this presentation, it would actually look slightly different, because Windows 7 didn't necessarily have a system-on-chip counterpart. We fell back into the Windows Embedded days, and if we went back a slightly further, before we even had Windows Phone, we also had this Windows Embedded, Windows CE, all these like miscellaneous products you only really work in if you're in that specific side of the IT industries. The one that kind of falls to the side of this, though, is the Micro Framework. Micro Framework is it's a great product, and it's actually used quite a lot in various parts of system design and device developers. And it's specifically designed for very, very small microprocessors. And I'll tell you a bit more about that in a second. Moving up from the Micro Framework, we have the Windows Embedded stack, and we still have that today. Windows Embedded 8 actually went to CTP the same time as Windows 8 was going through its beta testing, and it actually has the same Metro look and feel that we actually see on Windows 8 and WinRT. That Windows Embedded platform sits across a whole range of different architectures. So you've got Windows embedded automotive, which is used quite heavily in the US. It's around being able to control your car using Microsoft platforms, and Ford has a big relationship with this in the US with the Ford Sync product. And if you follow the Coding for Fun guys, you would have seen a whole load of stuff they've done with Windows Embedded Automotive in a project they run where they went on Pit My Ride and actually built their own car. Windows Embedded also has point of sale. It has Compact, which is commonly referred to as CE. And this used to be part of the mobile ecosystem, and it still is up until we see Windows Phone 8. Windows Phone 7 is actually built on top of Windows Embedded CE, and it has this custom interface on top of it. We have an embedded server. We have Windows Embedded Device Ready, which is like SCCM for all these little embedded devices. And then when we move up the stack a bit further and we've got more thicker, richer clients, we're then looking at Windows 8. So embedded are our lightweight mobile devices. Windows 8 is our big system on the chip, like Slate-style devices or desktops, and then moving into the server ecosystem as well. The micro framework is, though, what I'm here to talk about. And like I say, it's a great product, but it's different. It's very different to working with standard .NET conventions. The .NET micro framework is a subset of the .NET framework. It's very, very similar to Silverlight in that fashion, where you're coding with C#, you're coding with what you see as .NET conventions, but you don't have the full thing available to you. And it's quite obvious when you look at the devices you're using what you're not going to have available to you. And these devices, they're very, very small devices. You're talking about microprocessors that are like 386, 486 in terms of the processing power. So you're going back decades of computing power. You might be only dealing with kilobytes of memory when you're actually working with these little devices. There are loads and loads of these microcontrollers around, though. And the actual chipsets you'll find come in different form factors. And I'll discuss a few of them later on in the deck. The micro framework's great, though. It's .NET. It's very, very easy to pick up. And one of the great things about it as well is the devices that you kind of play with. They're inexpensive devices. You can pick them up for $10, $20. Actually very small as well. So if you've got a boss or a fiance or a wife or a husband that doesn't necessarily let you spend great amounts of money, you can try and sneak these things into your house and not actually get in trouble for that type of stuff. You should see my desk. It's actually covered in this type of stuff, but I managed to disguise it in various little pots and pans. Micro Framework, though, like I say, is a relatively old product. Does anyone remember Spot watches? One person? So in 2004, Bill Gates got a bit ahead of himself, and he introduced this concept of a Spot watch. And a Spot watch is a connected watch. But this was before we had Bluetooth. It was before we had Wi-Fi. You're going back a good decade ago. And the way that these watches were connected is Microsoft in the US actually set up specific FM frequencies, so radio frequencies, where they were pushing MSN data. So think of like SOAP web services over the radio. This is what we were talking about back then. And successful isn't necessarily a great word to describe these products. But certainly they were adventurous. The bottom corner photo here is actually Bill Gates presenting a Microsoft Spot coffee machine. So he actually put these MSN direct services inside a coffee machine because he thought it'd be a great idea for them to send you the weather forecast via FM radio, and you could read it while you're making your cup of coffee. They had some great promise. They got sold into people like Fossil and Sunto. There was loads of watches around, but unfortunately died in 2008. But the legacy still survives. .NET Micro Framework is around today. It's still very, very strong. In the fashion of everything in terms of Microsoft development, though, they open sourced the framework a couple of years ago. And it's an actively supported open source software product. 40% of the .NET Micro Framework 4.2 was actually contributed by the community. It wasn't actually written by Microsoft. It's overseen by Microsoft. Microsoft owns that specification. They manage the build process and the release process. So it's still very, very strongly governed, but there's much more community involvement. And that kind of follows the ecosystem around this embedded development throughout the other genres, as I say, such as Arduino and various other bits and pieces. There are two great sites if you want to try and download this stuff. You've got .NET .netmf.com. And that's actually the Microsoft portal. It used to be microsoft.com/.NET Microframework, but that one's kind of legacy. They've moved across to this one. It's a nice new design, very, very easy to use, a couple of tutorials and stuff on there. Then you actually have the Codeplex site with the source code and the bits and pieces you can download from there. Yeah, my slides move. So we're dealing with the .NET framework. So everything that I'm going to talk to you about, show you about today, it's exactly the same as if you was writing Windows apps, ASP.NET apps. We're using the same tool in the same languages. And so you would expect to be using Visual Studio. Unfortunately, I'm here on kind of the same day as Visual Studio 2012 got released, but we don't have the upgraded project support for Visual Studio 2012 for .NET Microframework yet. It will come. There's some specific extensions that need to be written around debugging two devices that aren't available, so you can't just use 2012. But you can use Visual Studio 2010 quite happily. And that's with all the plugin support. I work with ReSharper and various build processes and stuff like that on these devices, and it all just works. As of 4.2, you can actually write in VB.NET as well. So for any VB developers or Office developers that want to get into robotics, it's great for you guys because you can use your existing skills there. The first person that can actually put something like SharePoint on these things is going to be genius. All of this works with the Express versions as well. And there's a big, big advocacy around making this work on the Express versions. And that's because we're competing in the market with architectures like Arduino, which is coming on the C ecosystem. It's using Eclipse as the IDE. It's very, very much the open source ecosystem that they're competing with. So Microsoft is ensuring that everything they do in this space is going to continually be open source, it's going to be community engaged, and it's not going to have any commercial value to it. And it comes back to the software as well. .NET Microframework is completely free. It's the only product that Microsoft released in terms of being able to run a process that doesn't necessarily have a commercial attachment to it. Things like the embedded platforms, they all have to have the licensing fee attached. Whereas this one, open source, you can pick it up, you can build your architecture, you can deploy your hardware, and you don't have to pay any royalties across to it. Part of this open source and greater awareness and greater ecosystem as well is allowing us to work on Macs and Linux. And the two ways that they've managed to support this is by working with the Mono program. So you can actually use Mono Develop now and work with the .NET Microframework. Or, of course, you can run on a VM, and this runs quite happily on the VM. The drivers for the devices are normally work quite well on the VM as well. So I keep talking about form factors, and I've already mentioned .NET Gadgeteer once today. So I just thought I'll talk you through exactly what I mean by the different style of devices that are actually around. So we have Arduino. So Arduino is most probably the most popular product around this area, especially as a hobbyist developer. If you've dabbled with electronics, or you've walked into an electronics stores, or you've been over to the US and kind of walked around Fry's and stuff like that, you would have seen Arduino. In Australia, we have Arduino available in most standard electronics shops now. It's becoming more and more popular and very, very easy to use. So we actually have Arduino-style .NET Microframework boards as well. And I'll show you a few of them in a sec. We've also, as of the last year, had this new style device that's come out called a socket-style device. These have actually been designed to remove the knowledge of electronics away from using, remove your knowledge of electronics away and just allow you to focus on the programming and the rapid iteration and the prototyping, because it's very much a plug-and-play system. You can rip bits out and put things in, and you're not going to short stuff out that easily, unless you're me. Then you've got the development boards. These development boards are huge. These are, if you're going to go and build a commercial device, you would normally do so on a development board. They're pretty expensive as well because they're commercial-grade processors, commercial-grade silicon. They're normally coming with things like TFT screens attached to them. There'll be faster processors than you'd go and buy from a JCar or an electronics shop. When Microsoft was demoing a good couple of years ago now, Office on ARM, they actually demoed on these development boards. So if you go back to some of these videos, you'll be seeing Office and Windows being run on literally bare bones electronics kit. These are development boards, and that's what we're talking about. The other really important thing here is this last one, small form factor. So I'm going to talk you through some demos on this NetDuino architecture, this Arduino-style architecture. But you can actually import this across to small form factor microprocessors. So you're talking about literally taking the chip off the board, being able to load a .NET application on that chip, and then send it off and commercially distribute that. These chips, they're inexpensive. They're like $15, $20 to purchase. They fully support the .NET framework, and they're tiny, so you can build very, very small, flexible devices with them. So this is the one that I'll be working on today, Arduino form factor. I'm working specifically with a product called NetDuino Plus from a company called Secret Labs in the US, but there's a whole load of people that make similar types of products. And they all pretty much do the same thing. They have different levels of functionality, different levels of speed. The one at the end here, this is a standard NetDuino device. It's fairly similar to an Arduino in its look and feel and its processing speed. But the same company also make this NetDuino Plus, which is the one I'm using today. That has SD card support, has an Ethernet port on there, and a few other bits and pieces, faster processor. The one at the end is made by another company, exactly the same as the first one, but just different brands, different generics. The reason these are so popular, though, is because the Arduino ecosystem is huge. And the way it's ever expanded is by using this shield concept. And it's essentially Lego for electronics. I should have actually taken these out of the plastic before I started the presentation so they don't rattle in my microphone. But what I'll actually do is I'll pass these around because I don't necessarily have a big projector. But please be careful with them because they're electronics and they do short out pretty easily, and they are quite spiky as well. What I'll do is I'll just pass these down to everyone down here. What I'm going to hand out, please let them come back to me at the end of the day. You've actually got a GSM shield and a LCD display shield. They actually stack on top of one another, and they'll stack on top of these Arduino devices as well. They're very, very easy. You don't have to solder anything. They come as components. They're supported by the companies that produce them, so these are the electronics companies that produce them. Normally, they release only the C code, the Arduino code, but you'll find then the .NET community rally these together and finds the devices they like, and then they port these driver codes over to .NET, and we can start using them in our code if we need to. Arduino is a fantastic device, very, very easy to use, but moving across to .NET just allows you to port that skill set you already have onto these devices, and you can use it very, very easily. Some of these devices also have a pinvoke style functionality. So if we don't actually have access to .NET drivers, and you can't necessarily be bothered to write .NET drivers, we can actually go and take the Arduino style code, the C code, the C++ code, and pinvoke via .NET, and actually start calling into these native libraries. And that's great for when we actually have access to hardware where we don't necessarily want to spend time actually programming against very, very detailed level of integration into hardware devices. So the next one I just want to show you, but I don't have because it's shorted out, is the .NET Gadgeteer. This is the new one to the market, built by Microsoft Research originally, so the guys in Cambridge done a really, really good job on this. And it's, as I said before, it removes the barriers. You don't need to know electronics to use these devices. The Arduinos, they stack on top of one another. They can also be extended using PCBs and bits and pieces like that, so you can actually do what you like with them. And I'll show you some examples of that in a sec. But these ones, they're very much plug and play. So you'll go out and you'll go and buy a CMOS camera extension, and it comes with a ribbon cable. You plug the ribbon cable into the board, and you have access to a camera. The driver software is normally provided with the device. It's specifically engineered for the .NET framework. Very, very easy to use. They're made by a few different companies. So they're all licensed from Microsoft Research. They all follow the same specification, and most of the devices you can go and buy from one vendor will work with another vendor. They're cross-compatible like that. The modules themselves are all open sourced. So every time someone actually builds one of these hardware modules, they normally publish in the specification of the module on the internet, so you can actually go and look at the schematics. You can look at exactly how it's working. So if you want to build that knowledge of electronics up, you can do. What it also means, and the same for the NetDuino as well, that because we're in this open source ecosystem, we can go and download these open source plans, And you could actually license, you could go off and build your own board. You could send the boards to manufacturing plants in China, have a look at the, have your custom boards made up, or if you wanted to commercialize the product you're developing around this, go and download the schematics of the development boards and actually apply it into a commercial environment. So the Gadgeteer, coming back to Gadgeteer, the sockets you get here, you get a serial connection, so we're looking at fairly similar to the RS-232 serial connections that we had in the old days. Don't have to plug in a device and using that style connection. Or we have analog inputs, which is going to be your sensors and bits and pieces like that. They're made very, very easy to connect. They're visibly different. You can't plug an analog connection into a serial port. They're done for that reason. And as I said, they're vendor neutral. All of the people that are making these devices allow you to move between different vendors, and that's by design. This is a great piece of kit, and there was a guy actually talking in a presentation before this in the Azure track that's actually got these Gadgeteers. So if you get a chance to catch up with him, I highly recommend you speak to him because they're very, very easy to use. They're low barrier of entry to electronics if you want to get into this stuff, especially for kids as well. Okay, so 2 more slides, and I'll actually start showing some code because I know I can get boring when I talk quite a lot. So I just wanted to talk exactly when we talk about the .NET framework and we're talking about the micro framework and how we're getting it on devices, I just wanted to show an architecture diagram just to try and get it a little bit clear exactly what's going on. So fairly similar to the world of .NET we know on the desktop, you have your source code. You compile your source code. At this point, you then have to deploy it somewhere. So if you think of ASP.NET, you'd normally go through something like web deploy or FTP to get onto a server, and the server would start then processing that code. We're going through somewhat of a similar concept. We're actually packaging that code up and pushing it via USB onto a microprocessor. That microprocessor has its own, has a layer of firmware over the top of it. So if you wanted to, you could boycott the .NET micro framework altogether and just start writing machine code. But what the manufacturers have actually done following this specification is they've put this bootloader on there that has the .NET micro framework installed, which then interprets the code, and then you get obviously the standard IL that you get with .NET on the desktop. Once you actually start to run your code, if you're running it in debug mode, we'll actually open the socket back into the PC and allow you to have the full F5 debug experience from the device back into the PC. Which means you can start doing things with the electronics and actually start hitting breakpoints where you can start evaluating what's going on in the micro framework and have the same debugging experience as you would have on any other C# development. So I kind of covered these points, but I just want to clarify, why would you look at the micro framework? Rapid prototyping. This is one of the main reasons I use this stuff at work. If someone comes to me and says, hey, we want to go and build a puppet that you can stand in front of a Kinect and you can move your arms, and then this puppet starts moving its arms, and we need to do it quickly, and it needs to be in market in 3 weeks because it's going out in a display. This stuff is so much easier for me. I can pick it up, I can use managed code, I don't have to worry about memory management on microprocessors. I can wire up a couple of servos, I can start pulling things up and down, hook a network connection back to a Kinect, and I can actually churn this stuff out in 2 or 3 days. Very, very fast, rapid prototyping concepts. And if you look at the world of where we are with Kickstarter and this surge in hardware ideas, the ability to innovate quickly with hardware is very, very important nowadays. And it's exceedingly good for that type of stuff. The other reason you could consider working with this type of electronics is to hone your development skills. If you think of the ecosystem you're working on, many of the developers that come into the market nowadays would never have developed 10 years ago onto architectures, or even past 10 years ago, architectures like the 386 and the 486s. You're used to multi-threading, you're used to having loads of memory to bring stuff into cache and all this type of stuff. When you're working with microprocessors, it's very lightweight, very, very slow development, and very conservative in terms of threading. And you could just geek out a bit. Everyone wants to be Tony Stark. So having a couple of motors and arms moving on your desk and stuff like that, it's always a good idea. Most popular thing I've ever seen for the .NET Micro framework, if you're in development, is to actually integrate it into build process. And that's because people like to geek out a little bit more when ALM is involved. And two good examples of this, 30% of all offices I've worked in, someone has wired up a build light to a microprocessor. And that's when builds fail. You normally get sirens or flashing lights and stuff going around. And they're very, very easy to do by using something like the TFS SDK and plugging into this kind of thing. There's a Microsoft evangelist called Pete Brown who sits on both the XAML side and the micro framework side. And he was talking about this concept around deployment. So when someone actually built something and wanted to publish a live deployment, they went full nuclear mission control style, where they actually gave two senior guys keys, and they had to simultaneously turn the keys to actually push the deployment live into production. And all of this stuff was just people geeking out, playing with the micro framework, and then just bringing it back into everyday life to make their jobs a little bit more fun and make them feel like film stars. Okay, I'm going to jump into some code, and hopefully it's going to work. When you build with electronics, it's always quite interesting. I actually I'm trying to figure out how to use the new PowerPoint as well, which is even more interesting. So I don't have PowerPoint up on my screen, but that screen still has PowerPoint on it. I'm looking desperately at the AV people for help. I need my desktop. Yeah. That maybe. There we go. That was my problem. I've been using Win8 since launch, and I still haven't worked out the whole Control P thing. Okay, so this is going to be interesting because I have this tiniest little microcontroller sitting next to me, and I'm going to try and demo what I'm doing on this microcontroller to you via Visual Studio. So to prove I'm not lying and I'm not just going to bash some weird console app out, here is my microcontroller, and here is my breadboard. And I should have actually put the circuit up on the screen. It would have made life a lot easier. So the chips that are going around, you've essentially got one of these that are kind of sitting on the top here. And I've got a power supply that's being fed into a push-button switch, so standard clicker, which is coming out via one end into a ground via a resistor, and the other end is going back in as an input into the microcontroller. On the top here, same kind of setup, apart from it's an LED. So essentially, I've got hello world in terms of electronics. I have an input and I have an output. So what I want to try and do is explain to you exactly how easy it is to try and interact with this hardware. That's my backup plan. So I'll be coming back to that if this doesn't work. Okay, so Visual Studio 2010. File, new project, and as I said, it's very, very similar to what we're familiar with. We have a couple of different project templates. The one I'm going to use is specific to this architecture, and that's mainly because the guys at Secret Labs, they've put some, as I said, they've put some extra bits on the board which aren't conventional, things like Ethernet and bits and pieces like that. And what they've kindly done is they've extended the framework to allow me to access these without me writing custom drivers. So by using the NetDuino Plus application, I can actually dive straight into this. And what I'm actually presented with is something that's fairly familiar to most people if they've actually played around with it. It's a console app. It's just this static method that's just called, and then the thread will be disposed of if you don't do nothing with it. And yeah, it's that simple. I can hit F5 now, and it will deploy that empty app onto my microprocessor, and it will run. It won't do nothing, but it will run. I can put breakpoints and bits and pieces in like that. But what I actually want to do, excuse me kneeling down so you can't see me, I want to make an LED flash. This is going to be this is going to be Hello World Part 1. Okay, so IntelliSense is my friend. So I'm asking for an output from the microcontroller. So what I'm saying here is, hey, .NET, I want to send a signal out from the microcontroller one way, one direction. And yeah? Is that better? So I want to send it out. I don't want to necessarily receive an input. I just want to push something out. And what that's going to do is it's actually going to go to port 6 on the board. So where one of these cables is connected to, it's actually a numbered port, port number 6. It's going to send current through that port 6 via the LED and back out, and back down to be ground. So what I'm going to do is I'm actually going to say I want to send it to pin, let me check it, is number 6. So I want to send it to pin 6. And here, the pins are separated into two groups. We have analog pins and digital pins. And this is the same concept as I was talking about earlier, where you've got the serial style connections where it's digital. I can send binary data backwards and forwards. Or I've got these analog inputs, which are going to be things like sensors where they have variable inputs coming in. So an accelerometer, a gyrometer, that type of stuff. You're moving it around, and there's going to be a whole load of variation on there. So I want digital 6, and I want the initial state to be false. I then want to create a really simple loop. So this is just going to keep my thread open on a microprocessor. And then I'm going to say if LED read is equal to, I don't even need that, if LED is true, then I'm just going to set it as off. I'm then going to pause for a second or so. I think that's right. I'm actually going to take that out, and I'm going to just put that out of the loop. Put the else statement in. So if it's not already on, I'm going to turn it back on again. And then I'm going to sleep. And then what this is going to do, it's a never-ending loop. Just to keep the thing going, I'm going to hit F5. And now what that's doing, I'll actually pull this output up a little bit. So you'll see down here in this output display, is actually compiling the code, converting it into an assembly, pushing it across the wire onto the microprocessor. And it's actually doing it a lot slower than I can narrate it. And then eventually what I do is spin up a thread and then start running this application. It'll then attach the debugger, and it'll allow me to do any debugging I want to do with it. Okay, so it's actually it should actually be running. So if I put breakpoint in, so I now have my debugging capabilities. So I can move across, I can step in and out of the methods and do various bits and pieces. And then my LED will now it will now flash, and as long as I don't restart that application anyway, it will continually flash. Doesn't need to be attached to the PC at all. There's no coupling between what I've got in Visual Studio and what's on the PC. As long as I plug a power supply into the microprocessor, it's completely independent. It will load up, and it will just flash forever. It will keep going. So making things flash is always good fun, but sometimes you want to get an input. Sorry? I can, but the light is going to be so bright that you're not going to see it, just because of the stage lights. Yay. You can barely see it, but it is meant to be flashing. Or it's not at the moment. What's going on? Let's go back to my one I made earlier. Okay, so while this is not flashing still. Okay, I'm going to jump into the other project because I know I'm going to have issues with this progressively. So it's easier if I just open this other one, which the debugging is already working fine with. Okay, so the second part I want to show in this kind of hello world example is the ability to take an input. And it's very, very similar, very, very simple. Apart from in .NET, we have this added advantage of we have event handlers. And if you ever work with Arduino, we don't have this concept. You can't attach an event handler to a button input. So you're having to do it all manually. But the button input, it's very, very simple. We have this concept called an interrupt port, which is that as soon as we push the button, we're actually interrupting the current that's going through the circuit. It's a closed circuit. The interrupt port is going to interrupt that, obviously, and it's going to route the current back via the microprocessor instead. So that microprocessor is then going to see this electricity flow through it, and it's going to then tell .NET, hey, the button's been pressed. And it won't just say the button's been pressed. It will actually tell you the button is depressed, that the circuit is complete, and then it will tell you once that's been raised. So it lets you have a whole range of different scenarios in regards to a button. Now that all starts with me creating this interrupt port up here, and I'll zoom back into this code. And that's correct. My LED is attached to pin 9, so that's why the other one didn't work. So let's just give it one more try. A flashing LED. It feels like Christmas with the flashing lights and the dull lights. Okay, you may be thinking, where's the robotics? But I'm going to get to that in a sec, so wait a sec. Okay, so going back to this interrupt port. So, wrong Visual Studio. So what I've done, exactly the same thing. I've created this new interrupt port object, and I've said that I want to attach it to pin 6, which is the correct pin because I was testing it earlier in the speaker room. I then told it the resistor type that I'm working with, which is a pull-up, it's just because of the way the circuit's actually designed, and the specific interrupt modes. I can then attach to this event handler, which, like I said, it's going to just tell me every time this circuit is cut, it's going to raise this event. If I jump down into this, so this event, all I'm going to do now is just look for the value of 0, which means that it's actually been depressed, and then I'll come to the make web request a little bit later. So all I'm going to do here is turn off the other debugger, which is off. I'm going to hit F5, push this code across. I won't have a flashing LED, but I'll be able to hit this push button and actually cause this breakpoint to trigger just by me pushing the button. Okay, so it should have loaded. Let's see if it works. So me push the button. Ah, it hadn't loaded. Here we go. Did you see me push the button? And it hit the breakpoint. I like this. This is the first round of applause I've got in 4 years of speaking. It's quite good. Okay, so I'm just going to stop there. I'll talk about the web request stuff in a sec. So that's my Hello World demo. That's how easy it is to try and wire these basic input and outputs up. So just a couple more slides, and I'll carry on with the stuff in Visual Studio. Yep. While I was talking to you, the LED was continually flashing, which was confusing me because I was thinking it was still debugging. It will keep running. It's actually being powered via the USB connection. So the USB is pushing that 5 volts into it, which allows the chip to keep running. So even though you're detaching the debugger, the thread is still going. So this concept of Internet of Things, it's something that's been bandied around for a while now, and you may have heard it, especially if you went to the presentation before this in the Azure track, because it was called the Internet of Things. And it's this philosophy around everything that we know in our lives is becoming connected to the internet, and eventually we're just going to end up with Skynet because all the devices are going to be on the internet and we'll be able to talk to one another. But it's becoming more and more of a reality. And if you walk around your home, especially someone like me who's a complete geek and loves to buy these kinds of gadgets, you start to see more and more things appearing online. And this started up a little while ago in the US with something like X10, which was the home automation system. And I've actually seen people that have wired their whole entire house up to the internet, and they can log in via a cloud server and run a bath and stuff like that before they get home, and it goes crazy. But these devices are now becoming more and more commercialized, and we're seeing them more and more in the consumer space, which is why this stuff is overly important. A couple of examples here, and I pulled these off of Gadgeteer in the last week as I was refreshing my slide deck. There's a Bluetooth bulb. This is the weirdest gadget I've actually seen in a while. But it's a standard light globe that you can screw into your ceiling, but control it with your phone. So you can set the ambience and the color of your light bulb for a night of passion or a nice movie experience or whatever you want. All via Bluetooth and connected via a mobile phone. This second one here is called Smart Things. There's a couple of versions of this. I think Bell can have one as well. And what it is this is extending just, every house has a Wi-Fi router now, and they're extending this by offering a whole load of extra peripherals. So you can plug things in and control them via your Wi-Fi, and it comes with like a plug, and you can plug stuff into like your lights and bits and pieces in, and then your Wi-Fi adapter, so your Wi-Fi router automatically exposes these back to the web, so you can start controlling them. And Belkin are doing their range, and these guys are doing a range. We've also seen at work, we saw some around, teaching kids to potty train and to behave and stuff like that. And it was being able to do things like tag a toothbrush and a toilet lid. And it was gamifying this experience where as soon as they put the toilet lid down again, it gave them some extra points so that they could log on the portal and track their points. And when they was walking a dog, the further they were walking their dog, the more points they were earning. So they was actually enjoying this experience. And some of the things are just weird, like a light bulb, but some of them actually have some meaning in our life. Another presentation that I've been working on, I was looking at fitness equipment, and you can actually go into pretty much anywhere now and go and buy a pair of scales that, is it a pair of scales? Some scales that connect to the internet. You can stand on your bathroom scales and push all your public data up to the cloud. It's like, yeah, let's people see how fat we're getting. But it's becoming more and more important to people. They want to push all their lives onto the internet for storage, for safekeeping. And just because we're getting into this world of Facebook and apps and all this kind of stuff, and people are just coming to expect this type of stuff. I kind of talked through this slide a little bit, but we have this, consumers have this expectation. So when you're someone like me and we work in advertising, and we're having to build these utilities, these robots as such of, everyone expects everything to be online. It becomes more and more important to figure out how we can put our hardware online. The .NET micro framework eases this because we know from .NET that making REST-based calls isn't difficult. We can consume JSON, we can consume XML. So pushing that into a device should essentially be simple because we're going to transfer that same knowledge and skill that we have across the microprocessors. We can apply this to virtually every type of business. When I look across different verticals, we see, especially in consumer world, we're seeing all devices end up connected to the internet. And how important this is, again, it's quite fundamentally important. I'm a scuba diver instructor in my spare time. And I still have dive computers that I have to plug into my computer via an RS-232 serial port to actually download the data. That company that's making them is slowly going to die out because they're not embracing this concept of we expect everything to be online. We expect this Internet of Things. So me, as a lonely person that knows a little bit about electronics and a little bit about cloud computing, I actually took that RS-232 serial port and wired it up to an Arduino, sorry, a Netduino. And every time now I plug it in, it's downloading all the data off of the device to me and pushing it up to the internet. And I can now sync my scuba diving logbook through the internet, and it can download onto my phone, it can download onto my Facebook, it can download everywhere. And this is where it's becoming important. We're expecting this type of service from pretty much any type of hardware we're dealing with. And when we don't have hardware, Some of our clients at work are insurance companies, drinks brands, alcohol brands, that kind of stuff. We don't necessarily expect hardware, but they're still expecting to be able to engage with these people online via some type of experience. The last point here is also quite an important one. I've tried to stress that these processors, they're microprocessors, they're small. We have embedded devices, we have richer embedded devices, so your Windows CE, your Android devices and stuff like that, they have higher computing power, they have higher memory potential. But when we're talking about these lightweight devices, if we want to do anything complicated, we need to offload onto other devices as well. So having this connectivity piece is very, very important for offloading. So this is where my robot theory comes into it. If we know that robots are just the simple automation of tasks, wouldn't it be good if I could have a robot that could order me a pizza? It saves me having to think about it. Like this is something that everyone virtually does at least once in their lifetime. They order a pizza. And it's normally this process of having to find a menu, either install an app, call a number, log onto a website, go through the whole checkout process, and wait for your pizza to turn up. Learning what we've just learned, that I can push a button, and I can potentially connect my Netduino to the internet, I want to be able to push a button and order a pizza. And I know this seems fairly simple in terms of robotics, but this is only a level 200 session, so it's kind of the introduction to robotics. So take these ideas and develop them out into the next Terminator that can order pizzas. Okay, so I'm going to add HTTP into my project. And because I'm a demo failure today, I'm just going to talk you through what I've already got on the screen. If I can get a PowerPoint. Okay, so the first rule of working with of an Arduino, or a Netduino, I keep saying that for some reason. When you're working with them, try and know what environment you're going to present in if you're having to present something. Because I've spent the last week working with a Wi-Fi shield, which is currently attached to the top of this, thinking it'd be great to actually have this as a viable scenario, actually having a portable device that can connect to my home Wi-Fi. And then I can demonstrate that, and it sounded great. And I got it working. And then I turned up at TechEd, and I found out the one thing that beats a microprocessor is a browser, where you have to type the words TechEd 2012 into the browser before you can connect to the internet. So that was the challenge. So I've kind of moved away from that, and this morning I refactored my code, and I'm actually using the native Ethernet port on the Netduino Plus here. I do have the Wi-Fi shield on there, and if I have some time at the end and you're interested in how the Wi-Fi stuff works, I can actually show that to you, because it's a little bit different than how we make these internet connections. But where we were earlier, we'd pushed a button, and we was about to call this method called make web request. So as you can see on my screen, I have an Azure service, and I'm using two lines of code to call the internet. Exactly the same way as I would have done in ASP.NET. It's actually the same code. We're using, I think, the same namespaces, but don't quote me on that. System.net.webRequest. We're creating that object, which is a request object. It's a GET request. So I'm literally hitting this TechEd pizza website. I'm passing in my unique user ID. I'm passing in my favorite order ID, which is something that's cached in their database. They know what my favorite order is. And now every time I push that button, it's going to hit this pizza website, and it's going to place my order for me. And then what I'm doing, just to acknowledge this, there's no interface on my Netduino, which is kind of why I love this stuff, because I hate CSS. So my interface is my LED. So all I'm doing now is I'm going to get the response back. If the response is HTTP 200, so it's processed successfully, it's not throwing an error on the server, it's going to just flash my LED for me. And that way, I can push a button, I can see the LED flash. Having worked in a pizza shop, I also know that we have this concept called a make monitor. So this is the guy that's standing at attention, waiting for the order to come in. As soon as the order comes in, it hits his screen and he starts making the pizza. I've kind of replicated this, obviously not to that effect, but had a little small console app. So this is actually hitting the same service. You can see here, it's hitting the same as your web service, and it's just continually looking every couple of seconds to see whether any new requests have been made. And this is how I intend to prove to you that my little processor is going to go all the way through the internet, hit Redmond, come back again, and display something on my screen. That's that one. I'm actually going to be even more brave. I'm actually going to disconnect the USB port, and I haven't tried this one, so it's going to be interesting. So what I'm actually going to do is I've decoupled the debugger. I'm going to open up my console app, and I've already copied that code across, because if you remember, I was debugging that same code earlier, and I'd stopped it before it hit that breakpoint, which is why I hope it works. I'm just going to unplug it. So this is a 12-volt power supply, and the reason it's 12 volt instead of the standard 5 volt that I was using there is because the Wi-Fi shield actually drains a lot of the power. And then plug it back in again, and it's just going to boot up. I'm just going to give it a couple of seconds just to start booting up. I'm going to hit my button, and my lights come on, and I have my pizza. So I've now just pushed my Arduino, and I've now got my pizza. So I'm hoping you're kind of visualizing where we're going with this type of stuff. Very, very lightweight applications. They're very simple applications. They don't necessarily have to be. If you're a gun with electronics, you can do a whole load of things with this. There's a great company in Australia that ship to this region, and they're also based in the US, called Little Birds Electronics, and they have some great blog posts. Every couple of days, they stick stuff on Facebook and on their blog, and they have a whole load of different things. Like they've wired Siri into these things, and you can tell Siri to turn your lights on, and they're actually using relays, so same essential input-output concept, but they're relaying it into lamps and turning lights on and off. My fiance last year had a competition at work where they wanted to do the best Christmas decorations. And hey, I play with electronics, and Christmas decorations are somewhat electronical. So I thought I could trump everyone by going to get like 500 lights, fairy lights, and wiring them up to a couple of relays and synchronizing them to Christmas songs. I shorted out a couple of circuit boards and stuff like that, but it certainly was quite fun to actually play around with relays and just hooking up real-world objects to essentially the internet. We're just hooking up these Christmas lights so you could go onto our website, load an MP3 in, and it would actually synchronize these lights to the music while the MP3 is playing out the stereo. Let's just push my button one more time just to see the success of being able to process this picture order. I'll let you into a little secret. The original intention was to actually have someone burst through the door right about now with some pizzas, just because it was the pie coming up and you wanted to line your stomach. However, the guy I was going to get to do that unfortunately had to head back to Australia this afternoon, so I couldn't call in any favors. So no pizza for you, unfortunately. Okay, back to PowerPoint. So, my architecture. When I had this Metro slide deck, I thought I had to metrify everything. So I tried to metrify a pizza, which is interesting, trying to make a pizza square. But essentially, what we're doing now is, us as a user, we're hitting that microprocessor, we're hitting the cloud's then hitting the pizza store and saying, make me a pizza. Very, very easy, but very, very powerful. It's so powerful that my mouse doesn't work. Someone done it. And I'll show you the video to prove it. So I can't take credit for that. That was actually done by my company, but it was actually engineered in Dubai, and it was completely independent of the stuff I was working on. But if you work in advertising, and maybe if you don't, you'll be familiar with this concept of winning awards for your work. It's how they recognize effectiveness for their product. And the worldwide advertising awards are held in Cannes every year in France. And this actually won several awards around this effectiveness. And all they was doing is they was looking at this problem of we want to retain brand loyalty, and we distribute a whole load of menus each time. So why don't we kind of combine this concept of let's build this device, which is a magnet which people can stick to their fridge and kind of just push the button to order the pizza. And it increased sales dramatically. And because it was so easy, because you could just go up and go, yeah, I'm hungry, push a button, pizza turns up, it increased loyalty, it increased revenue. You'll be looking at that and thinking, it's stuck to a fridge, how does it work? Like, this is quite chunky, it's got these wires and stuff coming out to it. But this comes back to like my earlier thing around devices. Well, we have these tiny Arduinos, they're the same thing, but you sideload onto a chip, you solder the chip onto a board. This actually used Bluetooth, so it connected via Bluetooth instead of Wi-Fi to someone's phone, so they could configure it a lot easier than having to connect a Wi-Fi adapter. But Bluetooth 4, Bluetooth low energy, Bluetooth 4 LE, that will sit quite happily with an Arduino on a couple of AA batteries or a DC adapter, and just sit on your fridge and will work fine. Pizza isn't the only people that are doing this. Evian, my biggest water company in the world, as in bottled water, they actually have a similar device. They're using LCD-style display, similar to the one that someone's most probably stuck in their pocket when it was going around the crowd earlier on. But they're exactly the same concept. They're having a fridge magnet. These fridge magnets are becoming more and more popular. People are sticking them onto their fridge just to retain that loyalty and that purpose. And if you ever travel Qantas, although most people don't anymore, they have these things at the airport now. They're very light, very small terminals that you can go along and you can tap your Qantas card in and it checks you in. Exactly the same concept. It's a simple input from an RFID card and it checks you in. Why would I go and buy like big, expensive hardware to do something like that when I know within a couple of lines of code I can get a RFID shield on my Arduino, I can plug it into my Ethernet, I can have a little light on the top that flashes green, and I can check someone in just by touching the card in. It's becoming even more and more popular with this concept. I talked about where this came from. This is kind of where it's going. And I've put this in here because there was a statement that came out in the press a little while ago where a certain person in charge of Microsoft said, like, the bowels are going to be full in with slates and the mobility and on our wrists. And that was a very sweeping statement because Bill Gates had this vision in 2004 around the wristwatch is where things are going to go. Pebble Watch is the fastest selling piece of hardware on Kickstarter for both developers and consumers. MetaWatch, who came out of Fossil, who originally invested in the Spot program, are building their consumerized smartwatch, like this one. What this does is this connects via Bluetooth to my PC to get the data, so no FM frequency, no that type of stuff anymore. But these are in little embedded chips. They're virtually the same kind of chips that are on these microprocessor boards. And you write very, very small apps with a lightweight display. And they're great. Like, you can see, like, the best scenario I have is I go running, I have a Bluetooth heart rate monitor, I have my headphones in. All of these, like all of the devices are connected back to my phone. I can look at my watch, I can change the track of my music, I can connect to Runkeeper and I can see how my distance and that kind of stuff because it's coming out of the GPS on my phone. I can see my heart rate, I can see if I get text messages from my phone, all just by flicking at a watch. They're very, very small, lightweight applications. But this is where computing's going. It's becoming more and more consumerized, and we're going to see these in the next year in shops, and people are going to start to be wearing them. So having this knowledge around microelectronics is really going to benefit you there, because when you move into these devices, this is far from mobile world. This is very, very low power stuff, and you need to know how to do this kind of stuff. I was going to show you another demo, but I can see a clock here that tells me that I'm already running late, and there's some alcohol to get to, so I'm just going to skip over that. What I was going to talk through is actually how to connect these devices back to a Windows 8 app. Windows 8 being the theme for this event, so it could have been anything. It could have been a mobile app. It could have been some other bits and pieces. But obviously, if I'm ordering a pizza, I need to configure my device somehow. So we can open up exactly the same way as we've done an outbound TCP socket, a HTTP connection. We can do incoming sockets and connections, and that can be over HTTP, it can be UDP, it can be TCP. And this is when I talk about we connect devices with like connects to these. It's because we're actually tunneling information back and out in real time via network connections. If you don't want to use networking stacks, you can go and buy a serial port. You can use USB. You can even get UPnP stuff going on here. So you can put it on Wi-Fi, and then amazingly, your device can just start seeing stuff because UPnP just works. If you want to know a little bit more about UPnP and you're not hungover, come back to my session first thing in the morning, and I'll talk you through UPnP and how that works in regards to Windows 8. Okay, innovation. This is the innovation track. I'm presenting two topics in innovation and one in Windows 8. And the reason I'm doing two is because my interpretation of innovation is looking at a product and looking at how we can take that product and push it out of the box. So I've said to you, come here today and I'll talk to you about robots. I've told you exactly what a robot is. I've delivered you a robot that gets me a pizza. It wasn't what you was thinking. It was completely out of the box, but it fits into our lifestyle. It fits into our modern lifestyle. And this is where this kind of stuff is really, really important. The other side of innovation, I'll be doing last thing tomorrow, which is Connect. And I'm going to tell you exactly how Connect works. We're going to break it right down and look at how we can innovate and develop on top of Connect. But this type of stuff is really, really important. We have robots in our everyday life. Coming back to Pete Brown, he always says, make sure robots don't get too smart and make sure they're not talking to one another because we want to make sure they don't take over the world. But they're there. They're not humanoid. They're not walking around as telepresence machines, but they are there. And we have to start respecting that these are going to start making more and more of an appearance in our commercial world, in our enterprise world, on our build servers. Micro Framework allows us to build these types of things. We can transfer out skills across from ASP.NET, from Silverlight, from wherever, onto microprocessors. Very, very easy. Gadgeteer removes that barrier. If you don't know electronics, you can go and plug and play. The Arduino stuff, if you come from an open source background, if you know a little bit more electronics, it's a great area to play with. If you want to go hardcore, we can go and get them development boards for it. And yeah, our lives just now resolve on mobility. So when you're thinking about your next project, maybe think about how you can bring hardware into your life, how you can bring it into your desk, and how you can smuggle that stuff past your boss. That's it from me. I've clicked the wrong way, but enjoy the pie.